So in this topic, we will be discussing about coherent and incoherent addition of waves. So when you talk about coherent waves, let's take this example. Say suppose you have two different pins and you're creating a disturbance. You're creating a disturbance in these 2 points. Now the distance between these two, say suppose it may be same, it may not be same. Say suppose this is at the center. So then maybe the distance between these two is same. But when you talk about coherent source, we mean that the displacement that is being created is equal in both the cases for equal interval of time. And this is what we define as a coherent source. So if you want to define coherent source, so the displacement that is created is equal in equal interval of time, then the two or more sources are said to be coherent. So we can establish a definition for coherent source. Say suppose if you are creating a displacement of this magnitude and the same way another source is creating a displacement of this magnitude, so the displacement in equal interval of time are same, then you can say that these two sources are coherent and they always will be in a phase between them. Let me write this with a different color. Phase between the two sources is always constant. So this is how you define a coherent source. Now if you want to define an incoherent source, you can straight away take the opposite definition. If the two sources have unequal displacement in equal interval of time, then the two sources are said to be incoherent. So now I think we are clear with the definition of what is coherent source and what is incoherent source. So now let's look at the vector addition of these two waves. Now we know the net wave will be given by the individual displacement, or the net displacement will be given by the individual displacement of the two respective waves. Or in other way you can understand the net wave that is created by the addition of these two coherent and incoherent waves is the vector sum of the individual waves that we had already studied in our law of superposition. So let's have a look in our mathematical part. Now say suppose we are trying to add this two source. Now if you are looking at the point P, so how many waves will reach at this point P? If you try to look, let this be source S1 and let this be source S2. So we know that at this point, say suppose the source S1, let this be say Y1 equals A cos omega t. Say let Y2, let for this source, let the wave equation be represented as A cos omega t. Now say suppose if these two are equal, say suppose this two had been over here, if this two had been over here, then we know the resultant would be, Y resultant would be 2 of A cos omega t. 2 of a cos omega t if this would happen over here. But I am considering an arbitrary point P, and I don't know the exact look. What will be the net displacement at this point? The net, so what we can assume is there, say suppose S1 P minus S2 P. If you consider this S1 P minus S2 P, if it has a number, that is, if it has a complete wavelength, if it has a difference of a multiple of a wavelength, that is, say suppose n lambda. So if it has a displacement, the net difference is the multiple of a wavelength, then what we say is it has interfered constructively. This is known as constructive interference.